Thank you very much for the introduction. So I'll just get right into it. Even if laying hens in commercial poultry production are provided with all the food they need, they still love to forage. And this is because foraging is a highly motivated behavior that involves searching for food, pecking it, scratching, and also ingesting the food. Now, approximately 34% of Canadian hens, laying hens, are housed in enriched cages. And this number is going to increase by 2036 when the ongoing transition from conventional cage systems to alternative housing systems is completed. Enriched cages are regarded as a good compromise between conventional housing systems and other alternative housing systems, but they are still being criticized as restricting the expression of foraging behaviors in laying hens. And this is why we are asking the question, can we enhance foraging opportunities for hens in enriched colony cages? Now, this is where pecking blocks comes in. And pecking blocks are edible enrichment materials used as foraging substrate for laying hens. They have different nutrient composition. They also look different, as you can see in the pictures on the right of your screen. They also smell different and most likely taste different to the birds. So in our lab, we've used this, and we are also currently using these blocks in non-cage systems. But for this part of the project, we are looking at the use of these blocks in enriched cages. And as producers and stakeholders and students in different capacities in the poultry industry, we are asking three very important questions. First, can we use pecking blocks in enriched colonies? We're asking this question because currently they are not being used commercially in enriched colony cages. Second question is, do white and brown hens used in commercial egg production want the same type of pecking blocks? And we're asking these questions because we know these birds behave differently and they have preference for different resources in their housing. And our last question is, does their preference stay the same all day long? We're asking this question because we know hens have a habit of performing more foraging behaviors at dusk, which is towards the end of the day. And they do this to acquire the calcium they need that would help them in eggshell formation that takes place over the night, because hens need to calcify their eggshells. These questions are really important for us to answer because understanding laying hen preferences is crucial to optimizing their welfare. This is why our objectives are to identify pecking block preferences and strain differences in using pecking blocks, and also to determine if there's a time of day effect on the use of different types of pecking blocks. So we housed 120 decarb whites and 120 bovans brown in 12 enriched colony cages from when they were 18 weeks of age, and we had 20 hens in each cage. And in this experiment, we used 3 commercially available pecking blocks, but we offered them to the birds in pairs over 3 4-week periods. And the pecking blocks, we call them A, B, and C. And you might want to note down what they comprise because I'm going to be using the terms A, B, and C going forward. The A block comprised mineral and grains. The B block comprised mineral, grains, and molasses, while the C block was mainly mineral-based or calcium-based because it had the highest calcium content. So we made sure each cage got to experience the AB block, BC block, and AC block once throughout the experiment. And we started our comparison period from when the birds were 26 weeks old, which was the first period. And after each period of 4 weeks, we had 1 week of washouts where we took out the blocks before the start of the next period. And this is done to avoid any kind of carryover effect that might occur. But before we started the experiment, we had to do 2 very important things. First, we had to modify the pecking blocks. This is because pecking blocks come in different sizes and shapes. So we had to cut them down into similar sizes and shapes, as you can see on the right of your screen, in order to be suitable to be used in enriched cages. The second thing we did was to modify the enriched colony design. So the usual design of the commercial enriched cage we have now, we have the nest on one side in red at the top right of your screen and the scratch marks on the other side of the cage. But we had to switch things around a little bit to make this suitable for a preference test. So if you can see the after picture, we created 2 identical sides with a nest on each side, the scratch mat on each side, and we placed the pecking blocks in their containers and placed them on the scratch mat in order to facilitate pecking in a downward motion, which birds would usually do. We also switched the pecking block location bi-weekly in order to avoid side bias. So we measured the disappearance rates of the blocks by weighing them every week. We also measured the pecking or scratching behavior of the birds by mounting a camera on each pecking block once a week and filming from when the room light came on at 4 a.m. to the room light went off at 6 p.m. And through this, we're able to count the number of birds pecking or scratching the blocks throughout the light period, as you can see in the videos on the left and the right. And we sampled the videos using instantaneous scans at every 5 minutes across the light period. So in total, we had 169 scans for each day of filming, and we divided this into 3 equal time intervals, with the first set of scans being morning, the middle ones being midday or afternoon, and the final ones before the end of the light period being the evening period. So since we had 169 scans, there were 12 cages, 2 blocks in each cage, and there were 12 days of filming. It means we had 48,672 behavioral observations in this experiment, which is a lot. So we analyzed this data using SAS generalized linear mixed model to determine the effect of block type, pairwise comparison, strain, time of day, period, and their interactions. For results, we have the pecking block disappearance in gram per bird per day on the y-axis and the block by period interaction on the x-axis. So what stands out here is the B block, as we can see that the disappearance of the B block increases over time. But for the A and the C block, we see a more consistent pattern in how the birds use them. So what this tells us is the birds use these different types of pecking blocks differently. Here we have a block by time, block by strain interaction. And what stands out here again is the B block. We can see there's higher disappearance when it's offered to the brown birds rather than when offered to the white hens. And for the A and the C block, we see similar levels of disappearance. So what this tells us is there are strain differences in how the birds use the pecking blocks. Here, we have the pecking or scratching behavior. And we analyzed the results for the white and brown hens separately for this because they had a different distribution and they required different models to fit. So starting with the result of the Y strain, which is on the left of the screen, on the Y-axis, we have the number of birds per time interval, and on the X-axis, we have the pairwise comparison by block type. So what stands out here is the BC pairwise comparisons. So when the white hens have the BC blocks, we see more white hens pecking or scratching the C block rather than the B block. But if we take a look at the right of your screen, for the same BC pairwise comparison in the brown strain, we see more brown hens pecking or scratching the B block rather than the C block. So what this tells us is that there are strain differences or these strains have relative preference for different types of commercially available pecking blocks. And here we have my final and probably my most interesting results, because here we have a block by time of day interaction. And again, we have the result for the whites on the left and that of the browns on the right. So starting with the white strain, the blue bars represent the morning period, the yellow bars represent the afternoon period, and the brown bars represent the evening period. So by mere looking at the graph for the white strain, we can see a general trend for more birds to be found at each of the block towards the end of the light period. But this is more prominent for the C block at the PM or the evening period, which is the calcium-based block, as we see more white hens pecking or scratching the C block at this time. But in the brown strain, we see a more consistent pattern in how they use each block across the day. Although from this graph on the right, you can see they have a clear preference for the B block, but it's still more uniform in how they use the block as the day goes on. So from this presentation, there are a few things I would like you to take away. You've been able to see that laying hens in enriched cages increase their pecking block use over time. And also this white and brown strain have relative preferences for different types of commercially available pecking blocks. And what this knowledge would help us to do is to tailor enrichment materials to meet the needs of these two different strains we use in commercial egg production. And this would help to improve their welfare. Also, we saw that the strains used different types of pecking blocks at different times of day, as the white hens displayed more pecking and scratching behavior at the calcium-based block, which is the C block, before light out. And we think this is related to their calcium appetite, which tends to increase before the end of the day in order to help the hens ingest the calcium they need to make eggshells. And we saw that the brown strain preferred the B block, and they used it more uniformly across the day. I'd like to say thank you to my advisor, Professor Tenaldowski, and also my advisory committee, Dr. Alexander Harlander, Dr. Elijah Chiari, and all the helpers, the staff at Akia Research Station, my birds, all the funding agencies, and thank you very much for listening. I'll take your questions.
All right, thank you very much. It was a very interesting presentation. So I would remind the audience that you can use the Q&A chat in the chat room to ask your questions. So regarding your experiment, I was kind of fascinated by the fact that the white seems to be kind of really reaching out for calcium, whereas the brown, would you say is it that they don't need as much calcium, or maybe they are more interested in energy or other sources when they peck at the block?
Thank you very much for your question, Gregory. So yeah, that's definitely one of the things we've thought about. There's a possibility that the white hens have a more high calcium appetite compared to the brown hens, because we know that these two strains differ in their behaviors and also in their preferences. For example, we know brown hens consume more feed on average per day compared to white hens. So it could be one of the things one of the thought pattern I had is maybe the brown hens can get the calcium they need since they eat more feed compared to the white hens. Whereas the white hens might having a separate source of calcium for the white hens might actually be more beneficial to them since they don't eat as much feed as the brown hens. So there's definitely a possibility for that as well.
All right, thank you. So just a quick little question from the chat so we can stay on track with time. For your behavioral analysis, what was the experimental you used for the statistics?
So I mentioned earlier, we used the generalized linear mixed model for the stats. And for the disappearance data, we analyzed the whites and the browns with the same model because they fit into a very nice model. But for the pecking or scratching behavior, we had to analyze that of the whites separately and that of with that of the browns, because for the whites they had a Poisson distribution, while for the browns they had a normal distribution. And this is one of the things we face when we have behavioral data, because these birds not only differ in their behavior, but also even their stats is different. So we had to put them into different models, and that's where we had the perfect distribution for both of them.